We'd like to welcome everyone. We're glad you could join us for today's webinar, Accessible Technology, How a Screen Reader Works with STEM Content and More, with Zach Lattin. This webinar is made available by the Northwest Higher Education Accessibility Technology Group, which we refer to as Northwest HEAT. Northwest HEAT is a joint project of the Orbis Cascade Alliance and NWAC, the Northwest Academic Computing Consortium. Our mission is to advance our common goal of ensuring that digital services, information systems, learning technologies, and instructional and scholarly resources are equitably accessible to all users. Our overarching goal is to cultivate a community of practice among faculty and staff who support opportunities on their campuses. To do this, we provide a series of professional development programs, and we share these best practices and resources through a knowledge base we collaboratively support. If you'd like more information about the work of Northwest HEAT and how you can participate, we invite you to contact us at info@northwestheat.org. You can also communicate with us through the survey that we will share at the end of this session. But before we introduce our presenter, we would like to take a moment to share a few housekeeping details. This session includes a chat, which means that you can submit questions to our presenter throughout the session in the Zoom chat. Your questions will be addressed during the Q&A at the end of the session. You'll also want to know that this meeting is open mic, which means you are able to ask questions by simply unmuting your mic and then muting when you are done. Our presenter will guide us in how we can use that. Until that time, we ask you to keep your mic muted. This session includes captioning. You'll find instructions on how to access captioning in our Zoom chat. And this session is being recorded. We'll send an email notification to all participants when the recording becomes available at northwestheat.org, along with presentation slides. And now we will turn to Mary Ann Colgrove, Vice President of NWAC, to introduce our presenter.
Hi, everyone, and thank you so much for coming to our event today. I am super excited to introduce our presenter, Zach Lattin. Zach earned his Bachelor of Science in Mathematics and a Bachelor of Arts in Spanish Literature from the University of Washington. He has taught Braille in 3 countries and in 3 languages. Currently, Zach works at Clark College as an assistive technology trainer and IT accessibility coordinator. As a congenitally blind screen reader user and a lifelong Braille reader, Zach is acutely aware of access issues that arise in the context of STEM learning. In his off time, Zach enjoys being a dad and playing jazz pedal steel guitar for anyone who will listen. And Zach, we would love to listen. Today, Zach is going to help us explore some important questions, such as how do students with disabilities access STEM content? And what are some common barriers that they may encounter when reading STEM content? Zach will help us understand the basics of how a screen reader works. He will help us experience the specific issues that arise when screen reader users try to access inaccessible STEM content. And he will help us understand how technologies like Accessible MathML and MathCat can remedy those issues. And with that, I'm going to turn it over to Zach. Thank you.
Well, thank you. Thank you for that introduction. I did think about playing pedal steel, but you want to hear me talk about math, trust me. So yeah, this presentation is called Accessible Technology, How a Screen Reader Works and More. And just so we kind of have a roadmap of what we're doing today, I'll introduce myself again, and then we'll have some definitions, because I always think that math STEM talks need to have definitions. And We'll actually, this is out of order, I'm realizing, but we'll have a screen reader demo after we talk about some other stuff. And the other stuff is, I want to talk about user stories from students who used assistive technology during the remote learning phase, during what I call the remote learning phase of the lockdowns and the pandemic in 2020. And then we'll have some Q&A at the end. So I'm going to try and do a half an hour of slides and then about 15 or 20 minutes of what you all came here for, which is the live demo of MathCat. And it is going to be a live demo, so something could go wrong, but I play jazz in my off time, so we'll just figure it out if that happens. So a little bit more about me. I got my start in this field in 2003 as a student worker at the UW, the University of Washington. Go Huskies. So I want to put a plug in for if you have student workers or people who are just starting out in this field. I got my start as a student worker, and it's a great place to get us a start in this accessibility field. And I did teach Braille in the Andes after I graduated from college. I sold everything I owned and moved to Ayacucho, Peru, and taught Braille for 2 years. It was great. And then now I work as Clark College's campus IT accessibility coordinator. Every institution in Washington state should have an IT accessibility coordinator designated by policy 188. I'll just put that plug in there. But I'm really proud of the student trainings that I do. I train students to use assistive technology, and Clark College is right across the street from the Washington State School for the Blind and right up the street from the Washington State School for the Deaf. So we do have a unique set of students who come through our doors sometimes, and a lot of screen reader users, a lot of Braille readers, a lot of people who want to access math content in particular. So this is really, between that and my degree that I have in math, this is really what we're going to talk about today is near and dear to my heart, and this really is my dream job. I also do accessibility testing of software for adherence to WCAG 2.1 level AA and section 508 standards. We just hired a team of accessibility testers who got their certified trusted tester certification from Department of Homeland Security. I'm very proud of them and that work. And my contact information and email is on this slide. If you want to email me, you can email me at zlattin@clark.edu, and I will try to answer any questions that you have. So kind of to start with some definitions, I think we should all kind of agree on what assistive technology is, especially because there's becoming more and more of it every year, and it's even hard to talk about what it is sometimes. So very generally speaking, it's thought of as being used by people with disabilities, but many users use it without knowing it. It's any way that a user interfaces with a computer, phone, or tablet that adds a layer of interaction between the user and the device that isn't there for most users. And I like that general definition because assistive technology really is an extra layer, and that has a lot of implications, like the technical difficulties that I just found out about right before this session. So users who use assistive technology, computers crash all the time, and there are layers. The more software you have running on your computer, the more possibility for crashes there are. That's something I think that doesn't get talked about very much. Examples of assistive technology would be screen readers, speech-to-text software, SIP and puff switches. There's a hardware device that we'll talk about later in a user story called a Braille Note Touch, and screen magnification software are examples of traditional assistive technology. What does it mean for something to be accessible? There's kind of two ways to think about it. I think something's accessible when any assistive technology user can perform all of the functions or read all of the content in the same way that a non-assistive technology user with comparable skill set can. And that's really important when we talk about STEM in particular, because sometimes people say, well, gosh, I can't read this math book. I don't know what any of this means. And with all respect, it doesn't matter if you don't know what it means. It matters if the person reading the content can read and access the content and can know what it means. The other way to think about accessibility is that's the first way is the functional way. The second way is the conformance way. So the conformance way is more like it meets certain testable technical accessibility standards. And that is what we talk about when we talk about Web Content Accessibility Guidelines, or WCAG. NVDA, we're going to talk about a lot. Today, it's a screen reader. It stands for Non-Visual Desktop Access. And it's a powerful Windows screen reader. And it's important to say that this runs on Windows. If you have a Mac or an Android device or an iPad, you won't be able to run NVDA. It needs to run on a Windows machine. And it is free. It can be downloaded from www.nvaccess.org. So what is MathML? This is important to talk about too. And I was telling them that before we started that each one of these slides could probably be its own talk. And this is a great example of one that we're not going to dive too deeply into, but MathML stands for Math Markup Language. And it's a language. When we say language, I mean a markup language, which is a little bit different than a programming language. So I really struggled with how to write this out, but it's a coding language for describing mathematical notation, and very importantly, for capturing both its structure and content. And that is what the fact that it can capture structure is actually what makes MathML so powerful in terms of accessibility. MathML is actually part of the HTML5 standard now. I didn't know this until this morning. So we're making improvements here, and it's used to integrate mathematical formulae into web pages and other documents. MathCat it stands for Math Capable Assistive Technology. And I also struggled with kind of how to explain this, but if you know what Design Science Math Player was the way that we used to read MathML, accessible MathML, and MathCat replaces that. It was actually created by Neil Soifer, who used to work for Design Science, and now he made an open source free product that reads MathML accessibly. It can't work on its own. It needs to work with NVDA or something else. So if you install NVDA and then use the add-on store in NVDA, which I'm sorry, but a lot of this is beyond the scope of this talk. How to do that, if we spent all that time, we wouldn't get to the demo. So it can be installed with the add-on store once you get NVDA installed. And MathCat is a set of tools that, when combined with another screen reader, supports conversion of MathML to either speech or Braille. So MathCat is the magical thing that makes math on the web talk. And actually, I saw Neil Soifer present on MathCat at Accessing Higher Ground, and he did the bravest thing I've ever seen. He asked people, he Googled content on the web and just had MathCat read it, just random content. I won't be doing that today, but it's very likely that content on the web will be readable by MathCat in 2024, which is very exciting. So now we're going to talk about user stories for a little while. I had this great experience happen in 2022 where 19 blind and low vision students from a career program that we have in Southwest Washington called the YES program came to learn about a career in assistive technology, and it was awesome. There were 19 canes tapping down the hallway, and it was the coolest sound ever. So I did this icebreaker where I asked the students to share a time when they couldn't access a piece of technology because of their disability. And I very quickly started taking notes because I had forgotten that a lot of these students participated in a global pandemic, lockdown times. And so they had really interesting experiences. So we'll talk about some of them because they're important to understand what students go through when there's not accessible STEM content in particular. During the remote learning phase of the pandemic, a teacher sent a student a math worksheet that had been saved as an inaccessible PDF. The student was unable to complete the worksheet because their assistive technology couldn't read the content and no sighted assistance was available to them. So another student had a chemistry teacher who shared content with the class using Microsoft OneNote as images of text. The student, who was pretty tech savvy, tried to run optical character recognition software, but was unsuccessful because OCR technology can't interpret drawings and complex charts. Here's an example of a chart that you would not be able to OCR. If this showed up in any kind of inaccessible technology, any kind of inaccessible file, it would be very difficult to run optical character recognition on this chart and get anything out of it. It's an image of the Krebs cycle, which I barely remember from freshman biology. And it's a pretty complicated thing. A screen magnification user was provided with notes that had been photographed with a phone. Upon zooming in so that the text was readable for the student, the text became illegible. And sorry, I'm drinking water, became too blurry and pixelated to read. So there's a lot of lessons here. Hopefully there are takeaways. These are all things not to do. Here's an example of some tiny text that if you took a picture of it would not work correctly under screen magnification. So if you zoom in too far on a pixelated image, it's going to be pixelated and not work. If you have a text on a computer, you can sometimes, if you're a low vision user, you can use the Acrobat Reader function, the zoom function to zoom in, or other screen magnification software, and it works better. Another student, as part of an online learning exam, was asked to watch a video that was embedded in an inaccessible video player. This meant that the student could not independently start or stop the video because the transport controls were inaccessible. Transport controls are the play and stop button. So this is great. This is a really good one because this happens. I see this every day. So even if the video had been, even if the controls had been accessible, the video wasn't audio described. So the student still might have had some difficulties if the video contained a lot of visual content. This one's really near and dear to my heart because it happened to me a lot in high school. A student's screen reader became locked in 40-minute demo mode right before a huge math exam. The student, who was already stressed about the exam, had to restart their computer 35 minutes into the exam in order to continue using their computer. And this wasn't shared as part of the student's story, but this likely happened because the IT administrator forgot to renew the license for the screen reader. And I think if you hear screen reader and 40 minutes in the same sentence, you'll probably know that the student was also talking about JAWS. And this is something that happens when you use the JAWS screen reader, if your copy isn't licensed, and those licenses can run you anywhere from $900 to $1,600. So not everybody can afford a license. And so if you don't have a licensed copy of JAWS, it will just stop talking 40 minutes in, and it'll give you these scary error messages every time you try to use JAWS after 40 minutes. So, and if you don't restart your computer won't even talk in order for you to save your work and shut your computer down, which, as you can imagine, is a problem on a math exam during remote learning. A student was reading a science textbook with a screen reader, and none of the images had any alt text. So whenever the student encountered a picture, the screen reader just said image, image, image. The student believes that this adversely impacted their grade, and I tend to agree, given how many images there are in science books that are necessary for understanding the text. A student's district-issued laptop would crash every time they started their screen reader. Student used personal laptop while the issue was getting resolved. A student was doing science homework, and when they got to the 6th question, they encountered a keyboard inaccessible UI element in their online learning system, which prevented them from reading an article necessary for answering the question or complete the rest of the assignment. And again, the student had no sighted assistance. And yeah, was unable to complete the assignment. During the remote learning phase of the pandemic, a student only had a school district issued Braille note. So a Braille note, if you don't know, is a piece of specialized software that can be used by blind people in particular. It has 6 keys and it runs Android, and it's meant for writing Braille. And the student, because it was during the remote learning phase, was expected to do all remote learning on that device. So that device is a mobile device and can't run Zoom, Google Classroom, and Canvas and all of these things all at the same time. So the student had a lot of trouble keeping up, and the device would lock up. And so, yeah, so I'm gonna do a little bit of a context switch for a minute here, but I want to pause and ask if there are any questions about any of these user stories. Okay. So
Actually, Zach, can I ask a question?
sure.
My name's Jade. I work at the University of Puget Sound,
Okay.
and I do a lot of the OCR work for things that are going to go on to reserve. And some of those things are STEM related, and we'll have, equations and formulas and things like that in them. Do you have any suggestions on how we prompt someone to give us alternative text for those images? Because again, like the Krebs cycle, yeah, I remember that from biology as a kid, but I certainly couldn't provide, without somebody giving me the text, what they want that image to say.
Yeah, it depends on who you have access to, but it would definitely, there are guidelines for describing STEM images that you can look up online. And they are different than regular, other alt text. So there's all kinds of That's a really deep question. And
Yeah, sorry.
no, that's okay. It's a good question. And I think the answer is to research best practices for describing STEM images and find out how much capacity you have, because you're not going to be able to ask a publisher to do all this work for you. You might have access to a student worker or somebody who is describing it, and that's who you would want to train to do that work. So hopefully that's an answer.
No, thank you. Yeah. Appreciate that. It
Yeah.
is a lot of work
Yes.
to provide the best that you possibly can. Yeah.
Yes. Okay. So for the next part of this demonstration, this webinar, I'm going to reshare my screen and I'm going to share my audio. And so all of your computers are going to start talking with a synthesized voice. And I also want to say that I had some technical difficulties this morning with the default Microsoft voice not coming through my audio interface that I'm using. So I'm using eSpeak, which is not the most ideal voice. A lot of users don't like it, but it is a free voice, and it is, I personally don't mind it. So we will see what it sounds like. So I'm going to share my screen and my audio.
You have started screen share preview WND.
Okay, so
Screen sharing meeting participants can now see your screen alert. Screen sharing meeting controls window. Stop share Alt plus S button.
So this is what NVDA screen reader sounds like when you use it. The default voice these days is a little bit nicer sounding. It's Microsoft David if you're using Windows 10 or 11, which most of us are. And I may as well just start with the Zoom screen since that's where we are. But NVDA, the screen reader, reads all of the elements on screen if I navigate it with a keyboard.
Mute currently unmuted. Alt plus a button.
So it said mute currently unmuted. Alt plus
From
A
research
button.
everyone. Is it always that fast? Thanks. Alert.
And it's going to read the chat messages too. So yes, I actually slowed it down a lot. If many people tell me
From
to
Evan Gasser
slow it
everyone. I
down,
don't read as fast as that. Alert.
I can slow it down. It sounds like I might need to slow it down a little bit more. So we can do that. And this is a good time to tell you that if you install NVDA on your computer, all of the ways to access NVDA are in the NVDA menu, which is accessed by pressing Insert N.
NVDA menu.
Which I just did. There's not a easy way that I know of with the mouse to access this menu. So a lot of beginning users kind of struggle with where to get to the settings and how to close it. And this is how. You press Insert N.
Preferences submenu P.
And if I go to Preferences
Settings,
and Settings,
NVDA settings. General normal configuration dialog. Categories. List Alt plus C. General 1 of 15.
I will
Speech 2 of 15.
go to Speech.
Speech property.
I'm
Change button.
I'm navigating with keyboard only,
Voice
and I
variant rate.
will slow my speech
59.
down even more. By the way,
100.
this is how fast I usually have it,
Variant combo box left Alt plus A. Rate slider 100 Alt plus R.
because, and
90. 87. 60.
I have a lot of reasons
50.
for that, but
40.
how about this?
Rate boost checkbox not checked. Alt plus T.
Maybe this will be a little bit
Rate.
slower for everybody. Okay,
Desktop list.
so really quickly, I will show you how to install. I'll just show you where to find MathCat so that if you're using NVDA and you want to test this out, you can. Again, you go to Insert, you press Insert
NVDA menu.
N to open this NVDA menu. You go to
View log
Tools,
L. Reload plug run com create portable copy.
and I should have gone from the
Python cons add-on store A.
I should have arrowed down instead of pressing up arrow because it would have made me get there quicker. But one of the newer features in NVDA is this add-on store.
Add-on store installed add-ons all
And
dialog.
once you
Mickey
go
Riemann has left.
to this add-on store, you can
Diane Pod.
see sorry, I'm silencing Zoom notifications. I forgot I have an add-on that
has left the
does it by default, but that's okay.
search. Edit
So
enabled / disabled.
if
So
you
installed add-on.
start this for the
Tab
first
description.
time, you will not have access to this installed add-ons
Tab
page,
control panel.
and you will just
Lorry
have,
Hildebrand, including
let's
search.
see,
Edit updatable add-ons. List. Mariah Manners.
I'm having a little bit of
No add-on selected.
trouble
Install
here
from
for some
close
reason.
tab control. Updatable add-on. Installed add-on. Update available add-on.
Available add-ons. So this will be the tab where you can find MathCat. And there are a couple of other math add-ons and a couple of other accessible math add-ons, which I have not tried. So the one that we're discussing today is MathCat. If you want to install this from this screen, you would find MathCat. It's not going to be here because I've already installed
search.
it.
Available description. Actions button.
And you would press this actions button, and there's a way to install any add-on that you might want. So that's a little bit of an overview for how to install it. Now we are going to open Firefox and actually talk about some math. I choose Firefox because historically Firefox has been the most accessible web browser. Over time, other browsers come and go. Support for accessible math in browsers comes and goes as well. So that's important to think about. Chrome is the most notorious example. For about 10 years, they didn't support MathML. And so I'm sort of still mad at Chrome for that. They've caught up, but anyway, so I'm going to use Firefox. I was working with a student yesterday who used Microsoft Edge, and that student was able to read accessible MathML in Microsoft Edge. So there's ways, it seems to be work in every browser. So with Wikipedia, we can find a lot of articles that have MathML in them. Wikipedia uses MathJax, if you know what that is. So anyone who uses MathJax will be able to produce accessible MathML. So I am thinking about quadratic fields right now. I don't know why, getting a quadratic field vibe. So I'm going to type in quadratic field into the search.
Quadratic field, Wikipedia busy, link dump to content, banner landmark site navigation landmark menu button submenu main menu, link graphic Wikipedia, link graphic the free encyclopedia, search landmark search Wikipedia edit alt plus shift plus F button search, personal tools navigation landmark list with 2 items link create account link. And I let it read there for a second so that you can hear what should happen when a web page loads is a screen reader should just read it from the top of the page to the bottom. So if I didn't silence the speech, it would just keep reading. But since I don't want to hear all of this top content, I can just press the H key and keep navigating by heading levels. This is why those universal design things that everybody talks about are so important. Heading levels, lists and tables and image descriptions, because a screen reader user like me can just press the H key. Contents navigation landmark contents heading level 2.
And navigate right to contents, table of contents, heading level 2. If I press H again,
main landmark quadratic field heading level 1.
It'll say quadratic field, which is the title of the article, and it will say heading level 1.
Ring of integers edit link edit section. Ring of integers heading level 2.
Ring of integers is a section in this table of contents. So if I press down arrow, it should read
main article, link quadratic integer. Heading level 2 discriminant link edit. For a non-zero square free integer.
And here, this still kind of amazes me because I grew up in a time when math wasn't accessible on the internet. But if you just take a vanilla install of NVDA or a possibly other screen readers, although they're all getting better. JAWS is catching up, and I think this works with VoiceOver on iOS, sort of. You can press down arrow. I'm pressing down arrow, and it's going to read all of this math content.
D.
So D is actually math content.
The link discriminant of the quadratic field. K is equal to bold Q of open paren the square root of D close paren.
And now we're getting into the real, this is real math. This is what I would consider math that needs to be displayed on a Braille display or explored in more detail. So it said
K is equal to bold Q of open paren the square root of D close paren.
K is equal to bold Q of open paren the square root of D. So I'm trying to cover a lot in this presentation, and so this may not make sense to some, but if you navigate by character with your left and right
Space.
arrows like normal in a web browser, it will read character by character.
Space. K is equal to bold D L E
So
quadratic field.
the word
Space.
field, it will spell out if I navigate by character
F-I-E-L-D.
F-I-E-L-D, and then there will be a space.
Space.
And if I press right arrow one more time,
K is equal to bold Q of open paren the square root of D close paren space.
it will read the whole thing because it's a math object. This is a MathML object. So the way to drill down into this further or explore it further with MathCat is to press enter on it.
Math K.
And it says math. And then it says K, and it says it in a higher pitched voice to let you know that that K is capitalized. So now if I press right arrow,
is equal to,
it says is equal to. And if I press left arrow,
K.
It says K. And if I press left arrow again,
start of math.
It says start of math, so that you know that this is the start of the math content. And this is where the real power of MathML comes in and MathCat. And as I was saying earlier, the importance of MathML is that it captures the structure of, sorry, Zoom, we're getting Zoom alerts. I forgot to turn them off. So MathML captures the structure of the math content, which is how it's able to allow a user to navigate it in this way. So if we keep going right,
is equal to bold Q of open paren the square root of D close paren.
We have bold Q of open paren the square root of D close paren. And if I couldn't parse that, if my brain was if I needed to zoom in a little bit more, I can press down arrow.
Bold Q.
And it says bold Q. Normally when screen readers read content on the web or in a document, they don't announce bold or italics. And in fact, it's an accessibility best practice in general to not convey, not use bold and italics as the only way to convey information. But in math, bold things are so important that it was decided in MathCat that needs to be announced. So bold Q is announced because it's the field of rationals. So it means a very specific thing and it has a very specific meaning other than just a plain old Q. If we press right arrow,
the square root of D,
we get the square root of D. And if we press left arrow again, we get a bold Q.
Bold Q.
If we wanted to zoom in more to this square root of D,
the square root of D,
we could press down arrow.
In square root D.
And it'll say in square root D.
Out of square root. Out of square root.
And it'll say out of square root if you press right arrow.
Out of square root. Bold Q. The square root of D. In square root D.
And if I zoom in even more,
zoomed in all of the way,
it
D.
says zoomed in all of the way. So that is an example of, in my opinion, the power of MathCat. There are other, it's a lot to go into, but people, when you read a math equation, you're not necessarily going to read it character by character or word by word the way that you would read normal text. And it's important to be able to, as a screen reader user, read math equations the same way that that anyone else would read a math equation. The other thing that MathCat does, and I can show the MathCat settings dialog box in a minute because we're doing okay on time. But the other way that it can, there are a couple of different modes for navigating equations and a couple of different grammars for hearing how equations are spoken and read. And this also displays in Nimith Braille or UEB Braille on a Braille display. So that's very exciting for Braille readers because many blind STEM people will prefer Braille because it's just easier to read math than it is to hear it. It takes a lot of training in order to hear math. So let's keep reading about quadratic fields and see if we can find another equation to explore. So if I pressed escape, which takes you out of math mode, and if I keep pressing down arrow,
Is D.
it will read by kind of chunks. When you read math articles, it definitely chunks things up a little bit more, which is okay, but it does take some getting used to if you're not familiar with it.
If D is congruent to 1 modulo 4.
And we are zoomed way in or something if D is congruent to 1 modulo 4.
And otherwise, for D. Dot for example, if D is -1, then K is the field of link Gaussian rationals and the discriminant is -4. Dot the reason for such a distinction is that the link ring of integers of K is generated by open paren 1 plus the square root of D close paren divided by 2.
Okay, and if that was a lot, I could zoom in again. I don't know if this is going to be, we'll do one more example of this and then we'll move on.
Space.
So
Open paren 1 plus the square root of D close paren divided by 2 space.
So if we press enter,
Math 1 plus the square root of D.
it reads, I don't know why it reads not the whole equation sometimes when you press enter, but you could navigate it. I think I do know why. So 1 plus the square root of D, and then if you press right arrow,
Divided by
you get the divided by sign
2.
and the 2. And that might be enough for me to move on if I understand, oh yeah, 1 plus the square root of D divided by 2. I could probably move on. If I needed more information, I could zoom into this
Divided by 1 plus the square root of D.
1 plus the square root of D.
1
And it says 1 because that's the first thing.
plus
Then it says plus
the square root of D.
the square root of D. And so then I could say, okay, I get it. And I can press
Open
escape
paren 1 plus the square root of D close paren divided by 2.
and hear the whole thing again and then just keep going.
In the first case and by the square root of D. In the second case.
Okay, and I already forgot
From
that
the
there were
monophorial
2 cases. So
But
now
in
we
open-
have to go all the way back up here
Is generated by
and remember,
K.
oh yeah, we're talking about K, which is generated by
is generated by
1 plus the square root of D all over 2 in the first
open
case.
paren 1 plus the square root of D close paren divided by 2 in the first case and by
And
the square root of D in the second case.
the square root of D in the second case. Okay, now it makes sense. So you kind of read, I don't know if you've ever thought about this, but if you read math content, you are kind of reading it hierarchically. And so this is a way for a screen reader user to get that same experience of reading math content hierarchically. Another thing I will point out is that I've said it once, but I'll say it again. If you try this without MathCat installed, none of this content will be read. It won't even say blank or anything. It will just skip the math content. So MathCat is doing a lot of the heavy lifting in this situation. Okay, really quickly, I will show you the MathCat settings dialog box, and then I think we'll have some time for Q&A. I also, actually before that, I'll just demo something that I think every NVDA user and accessibility tester or screen reader user should know about, which is insert F7. If you press insert F7,
Elements list.
this is not MathCat specific, we're talking about NVDA now. You get this elements list, and by default, it is a list of all of the links on the page.
Wikipedia, the free encyclopedia 2 of 138 level 0.
And it said 2 of 138, so there's a lot of links on this page. And this is why it's important to name your hyperlinks and give them good usable names, because oftentimes with assistive technology, hyperlinks are stripped of their context, of their surrounding context. And this is a great example of
See also 40 of 138 level 0.
perfect. This random link that says see also.
Orders of quadratic number fields of small discriminant 30 also 40 of 100.
Oh, and we might be navigating by headings right now. Let me double
Filter
check.
by activate but move to button all cancel but type grouping links radio button check.
Oh no, those are links. So this see also link makes no sense if you just are tabbing through the web page or
Melissa,
navigating in this dialog box of links. So if you've ever wondered why it's important to give your links good names, good descriptions, this is one example of why. This dialog box is very powerful because you can
Headings radio button.
select headings, and with headings selected in these radio buttons, you can navigate this entire page by heading.
Review contents 1 of 2 level 0.
And it's hierarchically structured. So
Quadratic field expanded 2 of 2 level 0.
it says expanded and it says level 0. It really means level 1, but NVDA starts counting at 0.
Function with level 1 ring of integers edit 1 of 10.
The ring of integers. So we know that there's 10 headings in this section.
Let contents 1 of 2 levels.
I could
Quadratic key
close
collapse.
this. Oh, and that closes the whole thing.
Expand.
So I just really quickly wanted to show that dialog box because I think it's very important if you're training students on how to use NVDA, if you're using it to test web pages. This is probably the first stop for a lot of users on a web page.
From N Carpenter.
So
Quadratic field.
I'm sorry, I'm not paying attention to the chat and I'm silencing it. I will go back over it when we do Q&A and stop sharing my screen. But the last thing I will demonstrate is when
NVDA menu.
you install MathCat,
Exit X.
you
Donate
get,
save conf reset conf revert to saved.
again, I started at the bottom.
Quadratic.
I'm nervous.
Banner landmark.
Oops, what did I do?
NVDA preferences tools
Preferences.
Math CAT settings.
You get MathCat settings as an option here.
Math CAT preferences dialog.
And
Generate speech for combo box blindness collapsed.
there's a lot of different thoughtful considerations that went on with the design of this add-on. So you can decide if you're generating speech
Low vision.
for blind users or low vision users.
Blindness.
It changes the level of detail that is given.
Language. Combo box use voices language. Auto collapse.
You can select a language that's different than this NVDA's language, and this is spoken language, not programming language.
Speech style. Combo box clear speak collapsed.
There are several grammars, believe it or not, for reading math out loud. And the one that is pretty standard right now is called Clear Speak.
Simple speak.
There's another one that's called Simple Speak.
Clear.
And I think there's a couple more, but Neil has decided that these are the two that he's going to include.
Speech verbosity. Combo box medium collapsed.
You can change the speech verbosity, which I haven't played very much with that, but
Relative speech rate.
it is an option. You can also set MathCat to slow down your speech. So a user like me who reads text really quickly might need math read a little bit slower. So you could slow down MathCat's speech relative to NVDA's speech.
Make a sound when
There's a whole bunch of other
subject area to be used
kind
when
of stuff in this settings dialog box, but the one I really want to point out is this subject
make a
area.
subject area to be used when it cannot be determined automatically. Combo box general collapsed.
You know, if you're familiar with STEM,
Stephen check.
stuff is read differently depending on which
Natalie David.
section of math, which discipline of math you're studying. And so, you know, that bold Q of square root of D actually should have been read Q adjoin square root of D. And there's a chance that if you selected, they don't have abstract modern algebra in here, but eventually the plan is to have different grammars for different disciplines inside of math. And so I want to acknowledge that if you are deep into math, this isn't going to read how an instructor would read it in a class, but there are plans to make that
Speech
happen.
for chemical formulas. Combo box spell it out H2O
There
collapsed.
are ways that it can read chemistry because MathML does include the ability to display chemistry.
Okay button.
So
Quadrat.
I just wanted to demonstrate that. I do believe that we have 10 more minutes for Q&A. So
Screen
I'm
sharing
going
begins.
to stop sharing my
Audio set.
screen and
Mute. Currently.
your computer will stop
Stop
talking.
share all.
I want to apologize for that voice because that was not the voice I wanted to use, but hopefully you got the gist. Okay, I'm ready for questions.
Hi, so my name's Kendall. I'm a math instructor at Western. Oh, somebody also. Okay. Math instructor at Western Oregon. And a lot of what you were showing was related to web-based math documents. But as an instructor, everything typically is not web-based, and LaTeX is the, thing that we all use to write our math documents.
Yes, I love LaTeX.
When
And
when you compile to a PDF in LaTeX, can something like NVDA with MathCat actually read that? Or is there some sort of package that can be installed or anything like that that would make those PDFs more accessible?
Okay, this is a great, fabulous, deep question that I love. So a couple answers. Number one, LaTeX is just plain text. And so there is an argument, depending on who you're teaching, to teach them how to use LaTeX and how to read LaTeX with their screen reader. But it's also not for everyone. But I do want to point out that it is what I used to get my degree in math, because we didn't have MathML back then. So it's worth something. LaTeX can also be converted into MathML, accessible MathML. There are a couple of ways to do it that are beyond the scope of this talk, but I would say the best bet for your general audience that you're probably talking about is to convert your LaTeX to accessible MathML. And that accessible MathML can also live in a Microsoft Word document. We talked about the web in this presentation, but MathCat can read equations in Microsoft Word as well. So if you make your LaTeX into either an HTML file or a Microsoft Word document with accessible math equations in it, MathCat will be able to read those.
Awesome, thank you.
Yeah. I can look at the chat and see if there are other questions. So yeah, I'm sorry too about the fast speech. I'm looking at the chat and realizing that I had my speech too fast. So what do I use or recommend to read electronic math or STEM was a question in the chat. Or do I recommend hard copy Braille? So that's going to depend on the student's preference. But like I said, there's no way to, there's no substitute for Braille if you are a Braille user. Another thing I want to address, and please, if you have a question, interrupt me because this isn't a question, but I say this in STEM access talks all the time, and I'll say it again here. A lot of content creators think that it might be okay to create images of equations and then include the some kind of equation as in the alt text of the picture of the equation that they've included. And I think that in 2024, and this is my opinion, and this is not shared by everyone, but I think that is an unacceptable proposition in 2024. And the main thing I'll say is when you, as a traditional reader of STEM content, read a math book, would you like to read descriptions of the equations that you're reading, or would you like to read the equations themselves? And so the power of MathCat and the power of this technology is to give the user a lot of choices, like we saw in that dialog box. You can see, you can pick your grammar, you can pick Braille, we didn't talk about Braille, but you could pick a different, different Braille codes that people are familiar with. And if you have descriptions of equations, your user has no choice in the matter. And that makes it difficult, if not impossible, for some users to use the platform that does that. So there was another question. Yes, so there is something in the works. I'm addressing Jeffrey's question about LuaTech and a way to make accessible math in PDFs. I've heard about that and I'm really excited about it. I don't know very much about it, but that is something that is on my radar to try out. I don't know how it works, but my one caveat is if it does create those image descriptions of equations, make sure you also make the LaTeX source available to your user so that they can build it in another way or convert it to accessible MathML. As far as ebooks and OCR goes, this is not, as we talked about in the user stories, you can't OCR this stuff very well. There are some specialized OCR engines out there, and there's very promising stuff in the AI world, actually. But in general, this stuff can't be OCR'd. It needs to be somehow entered by hand or built, with LaTeX or MathType or MathJax or some way that creates accessible MathML. So are there any last questions? I think. Interactive dashboards. So this person is asking a question about interactive dashboards, and that's a little bit beyond the scope of this talk because those are image descriptions. But I would say make CSV data available to your users. Is the default equation editor in Microsoft Word still accessible? We at Clark College still use MathType because I've noticed some scary assumptions that Microsoft makes about equations, but I think it is getting better and there might be ways to configure it to be accessible, but we're still on MathType, so I don't know very much about the equation editor. So chemistry, we'll do this last one and then I'll hand it over to the great organizers of this event. But chemistry, I would say use MathML. You should be able to make everything talk with MathML. I don't know what to tell you about chemistry diagrams, molecular diagrams, except describe them concisely and follow best practices, and also talk to your specific student who you're creating the content for and address their specific needs. So thank you. Those were great questions.
So thank you so much, Zach. That was awesome. And Marianne here. So before we wrap up, we're going to try a new way to get feedback from everybody. We are going to launch a very short and sweet little poll. Please take a minute. We'll stay open so that you can respond to the poll. And then Gloria will also have some wrap up information.
So we want to share with you a link in the chat that invites you to look at the next webinar session, which picks up on this tremendous depth that Zach was able to demonstrate for us. You've really opened up new levels for us, and we thank you, Zach. And our next webinar, May 1st, will be easing the transition to STEM higher education for high school students with disabilities as they transition into higher ed. So we invite you to take a look at that session coming up. And again, thank you, Zach, for giving us new insights.
You are so welcome.